Hello. Today we are going to do question number 8 of A levels math 9709 variant 32. We are working on May June 2024 paper. In this question we are given with 3 points A, B and C and their position vectors are minus 2i plus j plus 4k. For B it is 5i plus 2j plus 0k and for C it is 8i plus 5j minus 3k. Line L1 is given which passes through B and C. We have to write the equation for line L1. So we know that L1 equals to A plus lambda B. Let's say A is equals to OB, which is equals to 5, 2, 0. And B equals to direction vector of the line. So B equals to OC minus OB. So it would become 8, 5 minus 3 minus 5 2 0. B equals to 3, 3 minus 3. So our equation of line L1 equals to 5 2 0 plus lambda times 3, 3 minus 3. So this is our equation of a vector. Moving to part B, we are given with the equation of a line L2 which is equals to minus 2i plus j plus 4k plus mu times 3i plus j minus 2k. We have to find the point of intersection of L1 and L2. When the a line intersects, it means vector x or I vector would be same. I equals to I of L1 equals to I of L2, which also means that 5 plus 3 lambda equals to minus 2 plus 3 mu. And since the lines are intersecting, so it also means that the j of L1 equals to j of L2. So which is equals to 2 plus 3 lambda equals to 1 plus 1 mu. So if we rearrange the two equations, it would become 3 lambda minus 3 mu equals to minus 7 and 3 lambda minus mu equals to minus 1. After solving them simultaneously, we get lambda equals to 2 by 3 and mu equals to 3. Now we can put the value of mu in L2 or we can put the value of lambda in L1 to find the coordinates of point of intersection. We are putting the value of lambda, so it would become 5 plus 2 by 3 times 3 and y coordinate would be 2 plus 2 by 3 times 3 and z coordinate would be 0 plus 2 by 3 times negative 3. So if we simplify it, it would become 7, 4 minus 2. These are the coordinate of point of intersection and we can write it as 7i plus 4j minus 2k. Moving to part C, we are told that the point D is on L2 and it is such that the length of AB is equals to length of BD and we have to find the position vector. If point D is on the line, let's say coordinate of point D is equals to x, y, z, we need to find the value of mu minus 2 plus 3 mu, 1 plus mu and 4 minus 2 mu. We have to find the value of mu. When we find the value of mu, we would plot this value and find the xyz coordinates. We are given that length of AB equals to length of BD. So length of AB equals to square root of 5 minus minus 2 squared plus 2 minus 1 squared plus 4 minus 0 squared. So it would become 49 plus 1 plus 16 square root. 49 plus 1 plus 16 is 66. So it is square root of 66. Now let's find the value of BD minus x coordinate of D, which is minus 2 plus 3 mu whole squared. 2 minus 1 plus mu whole squared plus 4 minus 2 mu whole squared whole under root. So if we simplify it, it would become 7 minus 3 mu whole squared plus 1 minus mu whole squared plus 4 minus 2 mu whole squared. Let us expand the bracket. A minus b whole squared is equals to a square minus 2ab plus b squared. So it would become 49 minus 2ab. 7 times 3 is 21. 21 times 2 is 42. 42 mu plus 9 mu squared plus 1 minus 2 mu plus mu squared plus 4 squared is 16 minus 16 mu plus 4 mu squared whole under root, and this was equals to square root of 66. So if we simplify it, it would become 9 mu squared plus 4 mu squared plus minus 42 mu minus 2 mu minus 16 mu plus 49, 1 and 16 equals to square root of 66. Square root and square root cancels. 9 plus 1 is 14 mu squared minus 42 minus 2 minus 16 is minus 60 mu. 49 plus 1 plus 16 is 66 equals to 66. These two get cancelled. So 14 mu squared minus 60 mu equals to 0. Mu times 14 mu minus 60 equals to 0. So either mu equals to 0 or mu equals to 60 by 14 or 30 by 7. Now mu equals to 0 would be neglected. Why neglected? If we look back into our equation, when mu was 0, we are on the point A, 214, and this is again minus 214. So we are going to take the value of mu as minus 30 by 7. So if we put this value into the L2, we get OD equals to 76 by 7, 37 by 7, and minus 22 by 7. These are the coordinates of point D.